In this problem, we're given some number n, and we want to make it divisible by 25 by swapping two adjacent digits around. And we also want to ensure that the leading digit is not a 0. So for example, if we have 5071, an answer such as 0175 wouldn't work because the first number is a 0. But a number such as 7150 would work. So the first thing to notice is that if a number is divisible by 25, then it ends in either 00, 25, 75, or 50. And that's the only thing we had to check for a number to be divisible by 25. If we see either a pair of zeros, a 2 and a 5, a 7 and a 5, and a 5 and a 0, then we know that we can make the number divisible by 25. And for now, let's not care about the leading 0 issue. So, yeah. So, we're given, let's just handle strings for now because that's easier. So we're given some string s, and then we want to move the digits that we need. So let's say if it's like, what are the examples we're given? Let's say 5071. 5071. And I think the best answer here would be 7150. So we want 7150. The answer is 4. Yeah, because it'll be 1, 2, 3, 4. So we want to move the 0 to this index and the 5 to this index. So it would be easy to just make this index 0 and index 1. So we can do that if we just reverse the list. So by doing so, now we have the number 17505, and we want this 0 to go to index 0 and this 5 to go to index 1. And yeah, so now we just handle everything backwards. So we have our answer, which was initially infinity, and then that is going to be the minimum of our current answer and solver S00. And then let's copy this 3 more times. So what this solver function would do, it'll take this string s and it'll take the digit that we need to go to 0 index, so it'll be 0 index digit, and then it'll also take the the 1 index digit. So it'll be 2 zeros at the end, then it'll be a 0, 5, then it'll be a 7, 5, and a 2, 5. Yeah, so since we switch this string around, we are doing it backwards. So that's why it's not 5, 0 and it's 0, 5 over here. And then we just output our answer such that if it's infinity, then we know we can't do it, so it'll just be -1, otherwise we output answer. Okay, so now let's handle this function which is called solver. So let's create solver, which takes in a string s, a char first, and a char second. Okay, so now we want to see if we even have these in our number. So what we should do is we should go through our whole number and we should count the number of each digit that it has. Each digit that it has. So let's just create a function which I'll call recount. Right, so void recount, we'll just take in some string s, and then we need some kind of array. So let's just call this digit count. which will of size 10, and it'll count the number of each digit that we see. So in like this case, we have 2 ones, we have 1 2, 1 4, 1 6, 1 7, 1 3, and this is what will be saved in this array digit count. So we just memset digit count to 0, size of digit count, and then for each character in our string, the digit that we have is just going to be the character minus 0, and then we just increase that count in our array, and that should be recount. So let's just call recount here. So now that we have this, since one case is 2 zeros, we have to check for that specifically. So actually what we can do is we can say if dig count of first minus 0, because first is a character, so if it's not 0, then we can use that, and we have to decrease this by 1, because if we have 2 zeros, then this takes care of that edge case. Otherwise we would just return infinity, because it's not possible. And then using the same logic, we can, so if digit count of second minus 0, so if we still see the second digit in our digit count array, then we know that we can make it into a number that can be divided by 25. So just be digit count second minus 0, otherwise we return infinity, because this number cannot be divided by 25. Okay, so now if we ever reach this point, we know that this number can be divided by 25 and has the characters first and second, right? So initially, let's create something called answer, which will calculate the number of swaps we do. So for s.size, let's find the first digit that we're going to put into index 0. So if si equals first, let's create this placeholder k as I. So while k, and this is because we want to move this character all the way till the first index, we increase the number of swaps we do, and then we actually swap sk and s of k minus 1, and then we decrease k by 1. And then after we do this, we just break, because we would have made our first digit all the way into the 0th index where we want that to be. So that's the first thing we do. And then using the same logic, so since now we've handled the first index, we start from the, since we handled the 0th index, now we start from the first index and go all the way till s.size. Oh wow. So if si equals second, then same thing in k equals I, and then while k is bigger than 1, what we will do is the same logic. We'll increase the number of swaps we do, and then we swap sk and sk minus 1, and then we just decrease k by 1. and then after that we just break and we should be out. So what this will do is this will count the number of swaps it'll take to get the two digits that we need, first and second, into the place into the right index. So now that we've done all this, we had to check the case of a leading zero. So if s of s dot size minus 1 does not equal 0, then we're done. So we just return answer. Otherwise, we have to try and make some other digit that's not the first two indices into our leading digit. So our placeholder k will be s dot size minus 2, and we'll create a bool called impossible, which starts as true. So while k is not the first two indices, we'll just check if sk does not equal to the 0 character. If that's true, then we know that there exists some answer, and then answer plus equals s dot size minus 1 minus k. Okay, why is this? So let's say after all the swapping, we get something like 578,000. So here there is an answer, which would be 570,008, and just be aware that since we do switch this actually means that the number is going to be 8,000,75, right? But the number of swaps we need to get from here to here is going to be the exact same as the length of this minus the index where this is at minus 1. So that's why we do answer plus s minus size minus 1 minus k, because that's the number of swaps it takes to put this 8 from here to here. Yeah, so once we do that, we break out of this while loop. Otherwise, have we decommitted k? No, we have not. We did decrease k. So now we're to check if it's impossible, we just return infinity because there is no answer. Otherwise, we just return answer, and that should work. And over here, since we do mess about with the contents in this array, we have to recount prior to each of these calls of solver. So we just do recount here, and we can just copy this, paste there, just one more time here, and that should take into account the leading zero, check if a number is divisible by 25, and yeah. What did I call it? Oh, recount. Oh, I'll give it the string. Recount s, recount s, recount s, recount s. Okay, so let's run e for perfect, 1 perfect, and then minus 1. Okay, that makes sense. So let's copy this, submit, and voila.